Have you ever heard of a space elevator? It sounds like a science fiction concept, but the idea has been around for over a century. A space elevator is a theoretical structure that would allow us to transport people and cargo into space without the need for rockets. In this video, we will explore the concept of a space elevator, its benefits and challenges. First of all, what is a space elevator and a geostationary orbit? A space elevator is a structure that connects the Earth's surface to a stationary platform in space called a geostationary orbit. The elevator would be anchored to the Earth's surface and extend upwards into space, using a cable made of strong and lightweight material such as carbon nanotubes. The cable would be held in place by the centrifugal force created by the Earth's rotation, which would keep the cable taut and stable. The idea of a space elevator was first proposed by a Russian scientist, Konstantin Tsiolkovsky, in 1895. A geostationary orbit is a specific type of orbit that allows a satellite to remain in a fixed position relative to the Earth's surface. This is achieved by placing the satellite in an orbit that is exactly 35,786 kilometers, 22,236 miles, above the equator and in the same direction as the Earth's rotation. This causes the satellite to remain stationary over a fixed point on the Earth's surface, which is useful for applications such as communication and navigation. The top of the space elevator would be anchored to a geostationary satellite, allowing it to remain stationary over a fixed point on the Earth's surface. This would enable the elevator to provide a constant and reliable connection between the Earth's surface and space. The elevator would be powered by a combination of electricity and gravity, with climbers moving up and down the cable using a combination of propulsion and braking. As we all can guess, a space elevator would have several advantages over traditional rocket-based space launch systems. Firstly, it would drastically reduce the cost of space travel since the energy required to transport people and cargo into space would be much lower. Secondly, it would be much safer than rocket-based systems since the risk of a catastrophic failure during launch would be eliminated. Thirdly, it would reduce the amount of space debris generated by rocket launches, which is a significant problem in space. Also, let's see how high we could currently build. The maximum height of a building that can be built depends on various factors such as the strength of the materials used, the design, the purpose of the building, and the cost. Currently, the tallest building in the world is the Burj Khalifa in Dubai, standing at 828 meters, 2,716 feet, tall. With advances in technology and engineering, it is possible that buildings could be built even taller than the Burj Khalifa in the future. However, it's important to note that building such tall structures also requires significant resources and investment, and it may not always be practical or cost-effective to build to the absolute limit of what's technically possible. So is it really possible? If the word space is connected to anything, it will surely come with major challenges. Here are a few among many others. Despite the many potential benefits of a space elevator, there are also significant challenges to overcome. One of the biggest challenges is the development of materials strong and lightweight enough to make the elevator cable. While carbon nanotubes have the potential to meet these requirements, they are still in the experimental stage and have not yet been produced on a large scale. Another challenge is the construction of the elevator itself. Building a structure that extends tens of thousands of kilometers into space would require an enormous amount of resources and expertise. The length of a space elevator would be around 100,000 kilometers, which is around 25 times the circumference of the Earth. It would also require an infrastructure capable of transporting these resources into orbit, which does not yet exist. Finally, the space elevator would also need to be able to withstand various environmental factors such as space debris and extreme weather conditions. To achieve this, the elevator would need to be equipped with a sophisticated system of sensors and control mechanisms, which would add to its complexity and cost. In conclusion, space elevators have been a popular element of science fiction films for decades. While the concept of a space elevator is exciting and has many potential benefits, it is still a long way from becoming a reality. The depictions of these structures have ranged from sleek and modern to massive and impressive, and they have been used to create thrilling and futuristic scenarios. The challenges associated with its development are significant, and the technology required to build it does not yet exist. However, its presence in popular culture highlights the fascination that humans have with exploring the unknown and pushing the boundaries of technology, and also continued research and development in materials science and space technology may one day make the space elevator a feasible and practical mode of transportation into space. Thank you for watching this video. Subscribe for more videos like this and keep watching.